Okay, so we're in SkyCiv. I'm going to add a beam, but before I do that, I'm going to check my units. Force units, I have pounds I want to work with and feet, but you have other options in there as well. I'm going to add a beam. I'm going to use the one that we used in the example. So 10 feet long, add it. There's my beam. But it is floating in the air right now, so I need to add some supports. I'm going to add a pin support. It needs to know the number of supports. Let's add one right now, and the support position. So I want it on the left side, and that's going to call that 0. All the way on the right is going to be 10, but I want it on the left, 0. There's my pin. I'm going to add another support. It's going to be a roller support on the other side. On the right side, when I click right, that goes to 10 feet because I had a 10-foot beam, so that aligns with that. Okay, great. So let's add a point load. So now this is pointing downwards, number of loads 1, load position. So if left is 0 and right is 10, I'm going to put it right in the middle. So I'm going to make that a 5, and that'll put it right in the middle. And the load magnitude, so how many pounds this is. Let's make it 1,000 pounds. Okay, and in the advanced fields, you can make it a dead load, you can make it a live load, wind load, roof load, rain load, snow load, all kinds of stuff. Let's just keep it a dead load right now. We don't need to get fancy yet. Let's add it. All right, so there's my point load right in the middle. And notice it adds the locations down here when we need it. So I don't need a moment or distributed load yet. We'll add that a little bit later. But I think we have everything we need. And this is a nice little table down here is keeping track of all of that. So I'm going to keep units in Imperial for now, and I'm going to add a section. So the section is basically, imagine the cross section of the beam itself, and add the stats for that. Moment of inertia, let's say we used 12 in our example. In the Young's modulus, or modulus of elasticity, we used 10 million. This is kips per square inch. So divided by 2, 5. Oh no, what is a kip? Kip, 2 pounds. I want to make sure. Yeah, okay, 1,000 pounds, of course. So kips are in 1,000 pounds. So that means 10,000 kips per square inch. Ah, that's annoying, but okay. Kips per square inch, that's fine. You could also add certain materials here as well. Structural steel, aluminum, carbon fiber, etc. Usually we're using structural steel, which is actually 29,008 kips per square inch, but our example we used 10,000 or 10 million, so I'm going to keep that the same for now. Submit. Okay, so now I have all of the shapes and stuff, and I have all the info that I need. So now I want to see the solve right up here. Click solve. There we go. So I got my free body diagram, which it made for me. So I got 500-pound reaction forces on either side. This also makes a shear diagram, which tells me what's the shear force or the perpendicular force to the beam on either end. So I got section 1, section 2. It tells me the values for this here, about 2.5 wide, 560.71 pounds of shear force. And if I keep going, I get a bending moment diagram. So that bending moment increases, maxes out right at the middle where the point load is, and decreases down to there at 2,500 pound-feet. So there we go. And I get a deflection curve. Now, this is not to scale, but I should be deflecting about 0.3 inches for that point load. And actually, you can find the, let's say I wanted the deflection at 3 feet. It would tell me how much that is as well at any certain location. But the maximum is down here at 0.3. So this does for us all the things we need to do in terms of deflection. It'll calculate the moment, give us the diagram, and it lines everything up, which I like too. So we'll probably pull screenshots from this as necessary. So that was a point load. Let's do another one. Oh, different output. This is saved to image, saved to PDF. Nice. So let's go back to beam setup. And instead of a point load, I can click on these and erase them if I want to. Let's add a distributed load. There we go. So starting position at 0, ends at 10 feet on the right. Let's say it starts at 100, ends at 100. So if this is going to change or not constant, you could add that as well. And you could also make that different types, but let's just keep it as a dead load for now. Let's add it. And there's my distributed load, 100 pounds per foot. I have everything I need to, keeps the same section. Let's solve for this. So I got my free body diagram, 500 pounds on each side, just like we did. Then I have my shear diagram. So that shear changes at a much more constant rate throughout the whole thing since I have a distributed load. And then my bending moment is now curved. So I have still max at the same point, right in the middle, but half as much, 1250 instead of 2500. And my deflection is much lower, 0.1875 on here. So SkyCiv is going to be a big help to us as we crunch all the numbers for the different types of beams we're looking for. And for the calculus friendly amongst you, you'll be interested to know that the shear force diagram, if I integrated this, I get the bending moment diagram. So this is really just the integral of this as that area increases and then decreases because the shear force is negative and going the other direction. So there we go. This is our SkyCiv quick demo.